NASA's recent release of the most detailed images yet of Comet 3I/Atlas has sparked a renewed wave of fascination, curiosity, and scientific excitement around the world. This interstellar visitor, only the third known object from outside our solar system ever observed passing through our cosmic neighborhood, has given astronomers an extraordinary opportunity to study something not native to our star system. In the November 19th press conference, NASA officials made it clear that despite the surge of online conspiracy theories, the comet poses absolutely no threat to Earth and is not, by any stretch of scientific imagination, an alien spacecraft or technological artifact. Instead, it is an ancient fragment of ice, dust, and cosmic material, an emissary from a distant star system, traveling on a long, mysterious trajectory through the galaxy. Dr. Tom Statler, NASA's lead scientist for Small Bodies in the Solar System Division, emphasized during the livestream that the appearance of such objects can profoundly change how people think about the universe. He noted that the presence of this comet expanded people's minds, encouraging them to consider how vast, magical, and unpredictable the cosmos can be. NASA's Exceptional Observation campaign drew upon the combined power of several major space-based observatories. The James Webb Space Telescope JWST, renowned for its ability to capture infrared imagery of distant and ancient cosmic objects, contributed high-resolution data that allowed scientists to examine the comet's structure and composition. Hubble, with its unparalleled long-term legacy of visual imaging, provided additional high-definition observations that traced the evolution of the comet as it journeyed deeper into the inner solar system. Meanwhile, the Lucy spacecraft, designed for studying Trojan asteroids, adjusted its instruments to record this rare celestial passerby. Together, these spacecraft created a rich dataset that offers one of the clearest views humanity has ever had of an interstellar object moving within our solar system. Comet 3I/Atlas was first discovered on July 1st by the Asteroid Terrestrial Impact Last Alert System ATLAS, a network of observatories intended to detect potentially hazardous near-Earth objects. However, 3I/Atlas quickly distinguished itself from ordinary comets. When initial measurements revealed the object's hyperbolic orbit, one not bound by the Sun's gravitational field, it became clear that this comet originated from outside the solar system entirely. Only two interstellar objects had ever been observed before: one I/Oumuamua in 2017 and two I/Borisov in 2019. The identification of 3I/Atlas therefore represents a rare scientific event, adding another piece to the puzzle of how matter travels through the Milky Way and how fragments from distant star systems might occasionally drift into ours. At the time of NASA's most recent observations, the comet was traveling through space at remarkable speed. When it was initially spotted, 3I/Atlas was already moving at approximately 137,000 miles per hour. As it approached the Sun, gravitational acceleration increased its speed even further, eventually reaching a staggering 153,000 miles per hour near its closest solar approach on October 30th. Although this velocity may seem extreme, it is consistent with expectations for an interstellar comet falling into the gravitational well of a star it has never encountered before. Fortunately, its trajectory ensures that it will remain a safe distance from Earth. According to NASA, the comet will not come any closer than roughly 170 million miles to our planet. It did, however, pass within about 19 million miles of Mars earlier in October, giving several orbiting spacecraft, including MAVEN, an excellent vantage point for collecting data. One of the most interesting datasets was obtained by NASA's MAVEN spacecraft, which produced a composite gas spectrum of the material surrounding the comet. Scientists informally referred to the fluctuations in this spectral data as science wiggles, small, measurable variations that revealed details about the chemical composition and behavior of the comet's gaseous emissions. These emissions form what is known as the coma, a cloud of vapor and dust that expands around the comet's icy nucleus when it is heated by the Sun. The coma grows brighter and more active as the comet approaches the Sun, providing valuable insight into the comet's makeup and how interstellar matter responds to solar radiation after potentially spending millions or even billions of years wandering through cold, deep space. NASA confirmed that the physical characteristics of 3I/Atlas align with what astronomers expect from a traditional comet. An icy core composed of frozen gases, water ice, hydrocarbons, and dust, surrounded by a glowing coma that intensifies as heat from the sun sublimates the material. As the nucleus warms, the gases trapped inside begin to vaporize and eject outward, creating a luminous halo that not only reveals details about the comet's composition, but also produces a tail that stretches behind it in the opposite direction of the sun. This behavior is entirely typical of comets and provides strong evidence that 3I/Atlas is a natural object, not an artificial craft or exotic structure. Nevertheless, the comet did not escape the modern internet's tendency to generate unfounded theories. Earlier this month, social media saw a rise in posts claiming that the comet's color had suddenly shifted in a mysterious or unnatural way. Images circulating online made it appear red at first and later blue, which some users interpreted as a sign of artificial origin or malfunctioning alien technology. NASA scientists and astronomers quickly dismissed these claims, explaining that the color variation was simply a product of observation conditions and changing brightness as the comet became more active near the sun. Additional analyses, particularly a preprint study authored by astronomers including Qiqing Zhang of the Lowell Observatory, clarified that the comet is, in fact, distinctly bluer than the sun when properly measured. The earlier reddish appearance came from observational artifacts and the way different telescopes or image processing methods interpreted the faint signals coming from the distant object. Zhang emphasized that there is no evidence whatsoever that the coma itself actually changed color. The apparent shift occurred because the coma became larger and brighter as solar heating intensified its outgassing, altering its visibility in different wavelengths. This kind of change is extremely normal for comets, especially those coming from very cold environments. When interstellar comets pass through the inner solar system, they often behave somewhat differently from long-period comets native to our own Oort cloud simply because they may contain different types of ices or volatile materials that respond uniquely to sunlight. Still, the overall pattern remains the same. Heat causes outgassing, outgassing increases brightness, and brightness can produce perceived color changes depending on the equipment used to observe it. The enhanced clarity of NASA's newly released images has helped put many of these misunderstandings to rest. The photographs, captured by multiple instruments with different wavelengths, show a beautifully structured, energetic comet with no evidence of artificial characteristics. Instead, the images highlight natural features such as jets of sublimating gas, dust trails, and the dynamic glow of the coma. For scientists, the images serve as a bridge to better understand how interstellar comets differ from their solar system counterparts. For the public, they provide a breathtaking visual reminder of the vastness and complexity of the universe we inhabit. Comet 3I/Atlas's journey through our solar system is temporary, but its value to scientific study is long-lasting. Every interstellar object observed offers a chance to learn something about the environments in other parts of the galaxy, places we cannot visit directly with current technology. The composition of its gases, the structure of its tail, and the nature of its nucleus all offer clues about the conditions present in the comet's home star system. Some researchers hope that by comparing the characteristics of multiple interstellar visitors, they may eventually be able to identify common traits or variations that reveal how planetary systems form and evolve across the Milky Way. The comet's incredible speed ensures that it will not linger. After completing its brief swing past the sun, 3I/Atlas will continue on its outbound path and eventually return to the dark, empty stretches of interstellar space. Yet even after it fades from view, the data gathered during its visit will contribute to astronomical research for years, possibly decades, to come. Scientists will continue analyzing the spectral information, comparing the jets and gas emissions with those of other comets, and examining the differences between interstellar and native objects. Future models of star system formation may incorporate details learned from 3I/Atlas, refining our understanding of how cosmic material moves through the galaxy and how pieces of one system might drift across the vast distances separating stars. As NASA officials emphasized during the press conference, the arrival of this comet is not just a scientific event. It is a reminder of humanity's ever-expanding capacity for discovery. With advanced telescopes, spacecraft, and observation networks, the human race is now able to detect and study objects that would have gone unnoticed for the entire span of human history just 1 century ago. The ability to capture detailed images of an object from another solar system is a testament to both technological progress and the enduring human desire to explore the unknown. The story of Comet 3I/Atlas is therefore not only a scientific milestone, but also a cultural one, inspiring wonder and curiosity as people everywhere look to the stars and imagine what else might be traveling through the cosmic deep, waiting to be discovered.